Circles C1 and C2 each have radius 1, and the distance between their centers is 1/2. Circle C3 is the largest circle internally tangent to both C1 and C2. Circle C4 is internally tangent to both C1 and C2, and externally tangent to C3. What is the radius of C4? So for this problem, we're going to want to draw some different segments in order to form an equation that involves the radius of C4 so that we can solve for the radius. So one natural thing we can try doing is we can connect the center of C4 to perhaps the midpoint of the segment whose endpoints are the centers of C1 and C2. So this point right here. Now if I connect the two centers with a straight line, by simple symmetry, this will form a right angle. So first we should find the radius of circle C3. So in order to do this, we can notice that the distance from the center of C1 to the leftmost point of C2 must be 1/2. This is because the radius of C2 is 1. Similarly, the distance from the center of C1 to the rightmost point of C1 is also 1. Therefore, this distance from the center of C2 is also 1/2. Therefore, the diameter of circle C3 is 3/2, and the radius is 3/4. Next, we're going to let the radius of C4 be r. Which is what we're trying to solve for. So next, we're going to consider the segment that connects the center of C2 to the center of C4. So we'll use green. If we can find the length of this segment, then we can use the Pythagorean theorem to form an equation in terms of r so that we can solve for it. So to find the length of this green segment, what we can do is we can actually extend it to the boundary of C2. And the reason why we're doing this is because C4 is tangent to C2 externally. We can then say that the distance from the center of C4 to the boundary of C2 will also be r. Therefore, the distance from the center of C2 to the center of C4 must be 1 minus r. So by connecting the centers of C2, C3, and C4, we obtain a right triangle where the side lengths are 1/4, 3/4 plus r, and 1 minus r. So by using the Pythagorean theorem on this right triangle, we can solve for the radius. So the rest of this problem is pretty standard. We're just going to apply the Pythagorean theorem on this triangle. So 1/4 squared plus 3/4 minus plus r squared is equal to 1 minus r squared. So I will expand both sides, noting that the r squared terms will eventually cancel out. So 3/4 plus r squared is 9/16 plus 3/2 r plus r squared. 1 minus r squared is equal to 1 minus 2r plus r squared. So the r squared terms will cancel out. 1/16 plus 9/16 is 10/16, which is 5/8. So we have 5/8 plus 3/2 r is equal to 1 minus 2r. And we'll add 2r to both sides in order to isolate the r terms. So 7 over 2r. And we'll subtract 5/8 from both sides to get 7r over 2 is equal to 3/8. Lastly, multiply both sides by 2 over 7 to get r is equal to 3/8 times 2/7, which is equal to 6 over 56. And this simplifies to 3 over 28. So the answer is D.